Hello students, this is the second video lecture of kinematics. Motion in one dimension, that is motion along a straight line. Kinematics, this is 2. Video lecture number 2. Average velocity or average or mean speed is a scalar quantity is defined as total distance covered by total time interval. So this is the expression total distance by total time or delta is total. Average or mean velocity, that is a vector, is defined as net displacement, means the resultant displacement by net time interval, like this. Now, this is the physical state, rest, motion. Uniform motion are of two types, uniform and non-uniform. Now, non-uniform motion or variable motion with constant acceleration means to distinguish rest and motion, we have selected position, time and a frame of particular frame of reference to distinguish rest and motion as physical quantity. Now to distinguish uniform motion and non-uniform motion, we have to consider another physical quantity called acceleration. Acceleration is a vector and it is defined as rate of change of velocity. So change in velocity divided by the time interval. So it is final velocity is v2 and initial velocity is v1. So v2 minus v1 by d2 minus d1. d is the final time, d1 is the initial time. That way also we can write. Also we can write, say, v minus u by d. This v is the another notation, more popular notation. V is the final velocity, u is the initial velocity by time. Time interval is t denoted by t. So this is a vector quantity, and as usual we may have three possible values. Acceleration may be 0 or a null vector, where acceleration is 0 means the velocity is not changing, so it is a uniform velocity case. And acceleration may be positive. So acceleration is positive means final velocity is greater than initial velocity and it is different. So the positive acceleration indicates positive change in the velocity. So it has magnitude and direction, so both are changing. Negative acceleration or deceleration or retardation is when the final velocity is less than the initial velocity clearly. So that is another possibility. Now we will discuss the graphical representation of different states. For example, we are taking object at rest. Object at rest. So object at rest, the condition is xt. The position coordinate is not changing with time, so the instantaneous position coordinate is a constant. Now we can have a data table like this. Time is independent variable and xt is the position coordinate. Instantaneous is a dependent variable. So time is changing, but the position coordinate is not changing. Say 2 meter is remaining constant. So this indicates rest rate. So we can plot a graph. The dependent variable is taken along the vertical one, that is on the y-axis, and independent variable is taken at the x-axis. So clearly, with respect to this data table, the graph is coming like this. So it is a straight line parallel to positive time axis. A straight line parallel to positive time axis. This is called position versus time graph for object at rest. Now you can ask that what is the importance of this graphical study? The importance is, suppose you are given a graph, position versus time graph of 4 objects, like object A. This is object A graph, which is stationed at Delhi. It may be a car, maybe a two-wheeler, whatever. Object B is in Mumbai. Its graph is given. You don't have the direct access, or you know nothing but know about the object. C is a object which is in Bangalore, and D is another object which is in Kolkata. Now you don't have the access, direct access, or you have no information about these 4 objects. Only you have this graph, position versus time graph. Now with the help of graph we can say whether the object is in at rest or in motion. Clearly, object for object A, it is a straight line graph parallel to positive time axis, so it is at rest. All others, object B, object C, object D are in motion. So this is the importance of graphical study. Now, uniform motion. Amit, cross to the